Hey everyone, and welcome to the first of many videos to come of the Gdx-AI library tutorial series. Now, this series is going to be more pieced into different sections of the AI library that's provided alongside the LibGDX framework. It's an additional library you can tack onto your Gradle build when you first set up your project. And just a few things about it. What it's good for is getting artificial intelligence quickly implemented into your game without having to hard code a lot of it yourself. There's finite state machines, messaging, and steering behaviors, various things like that, and they work wonderfully from what I've tested and used so far after reading a lot of the documentation of what little there is. But I think the one thing that will help people the most is actually seeing things be implemented by hand, and that's what I kind of hope to do for these videos, as most other videos I have are just kind of showing you bits and pieces of features you could put into your game or how to approach certain problems, various little things that add some nicety to the gameplay feel of your game. And so with this introduction video, what we're going to be doing is implementing a very basic arrival behavior. And you can see down here I'm using this arrive class, and that is in the steering behaviors. So I'm kind of gonna start with steering behaviors, as those are the easiest to get off the ground, and then we'll move into most likely collision avoidance and pathfinding, group steering behaviors, hiding behaviors, different kinds of finite state machine, artificial intelligence, stuff like that. It's that's kind of the order I want to go in, is get in with steering behaviors, because those are the easiest to really get off the ground. So just to kind of show you what I have so far for this introduction video. As I mentioned, we're going to be starting with the arrival behavior. And so what I have here is kind of a generic Box2D setup that I've had in several of my other videos. If you haven't seen it before, it really isn't a lot going on here. It's just the Box2D debug renderer in a Box2D world with a few bodies thrown in there. And I have a reference to this body that I take control of, and I use the arrow keys to move it around, which you guys have probably seen me do. And this body isn't controlled by anything, but watch this as I move my character away from it. And you'll notice it follows me wherever I go, and there's no references to it or anything. It's just been told to do that. That's just how it is known to move. It just responds and it rotates to view me. As you can see, that line there is angling the right way. When the line is to the right like that, like how it is now, that means it's facing north. That normally means, like when it's on the right hand, the 90 degrees left of that line is the front facing. And you'll see how it just kind of follows me, and it'll respond to however fast I'm moving. I can push it around, doesn't matter, but as long as it is at least within 3 meters of my body, then it will just continue moving to try and get to me. So that is called an arrival behavior, and that is because it has me set as a target. And now this, you could set the target to be anything. You could set it to be any body in your physical world, and that's something that's really nice. You can control that behavior. You can set the behavior whenever you want. You can turn that behavior off whenever you want. And so it just has a lot of flexibility to it. So I think the next thing we should probably do is start getting into some of the code. Now that you guys can kind of see this behavior, you can control how far also this interaction is, like where it should stop trying to get to me within a arrival radius. So again, let's just jump into the code real quick and see what I kind of have set up in this avoidance state right here. So just kind of for mentioning this, a lot of the code is really straightforward, so a lot of it will look similar to what's on the Gdx-AI tests. Now, there are a few changes that I have made that I noticed in the tests were a little outdated. There are a few methods that were deprecated or not even in the library anymore that were changed around, and so I've kind of been working through all that just to try and clear it up. And so hopefully those who are wanting to learn it won't feel intimidated by these approaches, as they're really easy, and getting into artificial intelligence is kind of that thing that you don't want to get into just yet, especially if you're just starting. But I want to make sure people know that they can use this stuff right out of the box, and it's really quick to just get going as long as you have kind of read through what's going on and know a little bit about how you want to implement things. So um, as you can see, I have a few of these entities here. The particular one we're going to be working with today is the Box2D steering entity, and that's just a layer of abstraction that I've kind of created to where I can extend these entities into another entity, such as a player class or an enemy class, etc., or have an enemy class that has a steering entity that it watches and has a reference to, and you can modify the behaviors and whatnot. But for now, I'm just using this as a basic class. And let's step through the state code we have. So we have a world, a debug renderer, an entity, and a target. And those are both of type steering entity that we have here. And I set up the world, I create a body, a circle body, and then I have this entity and I give it a body to work with. And I set a bounding radius for that body. So that's just kind of the working radius that it gets. You know what, that should actually be 10, and this should actually be 10. That was kind of a correction I should have made prior to recording, as that's the radius of the bodies. And I'll explain what that number is for in just a second once we get into creating the Box2D steering entity class. And right here I just have some walls that I threw up. You saw the green walls, I'm sure, and that's just so we can easily see that we're moving about the Box2D world and making sure, like, it gives us a point of reference so our eyes can kind of follow along easier. And then I have this arrive vector2 class or object, and you can kind of see set time to target, set arrival tolerance, set deceleration radius. Now these are how you can fine tune how your arrival behavior is going to act. So like, you're giving this entity this behavior, as you can see, entity.setBehavior, and then there's a target for it to get to, and the target is actually the player that I can control, the little circle that I control. I just called it target because that's what I'm using it as for the main entity to get to or arrive at. So we'll get into this most likely a little bit more in the next video. I don't want to make this too long. I just want to get the basic interface set up by recreating this Box2D steering entity with you guys. And this is just basic input control, so I'm just kind of changing the velocity of that target body again that I'm using. And I have this update method that's attached to the steering entity, which I'll also cover most likely in the next video. And then I just lerp to my target. That's just my camera. This is all extra stuff that doesn't really matter. Creating my circles, creating my boxes, camera lerping, and I just have this method that they actually use in the tests that can turn Box2D bodies or fixtures into sensors. So let's see. I'd say the best way to go about this is we're just going to delete this Box2D steering entity altogether. So now that we know what we're working with, we're going to try and recreate the same thing that we had going for us. So we're just going to delete this. Don't worry, I have it backed up, so it's not really going to make me lose any work or anything. So we're just going to make this Java class again, Box2D steering entity. Okay, and what you have to do is in order to allow a game object or an entity to have a steering behavior, it has to implement steerable, and that kind of tells LibGDX or Gdx-AI that you have a steerable object, and the behavior is what controls that steerable object. So you have implements steerable, And the vector2, the reason I use that is because of that's the type of position we're working with. Box2D uses vector2s as the position to know where they are in the world. So that's why we're typing that with vector2. So you notice we got a little error here, and that's because we need to implement those interface methods. And you'll notice it's pulling from two different interfaces, this limiter and steerable. So the steerable one is what it kind of uses to steer the game object around, and the limiter is what determines like the kind of restraints that this steerable object has, like such as how fast it can turn, how fast it can move to be able to get to its target, or just small things like that. So let's get those implemented. And again, this is going to be kind of grindy, as a lot of these are just one-line methods. They pretty much read out what they are just in the method signature, just the name of them. You can see get position. I'm sure you can imagine that's just the body we pass and returning the position of that body. So let's set the constructor up real quick. We're going to have a public B2D steering entity. And like we saw from the previous state class, AI avoidance, or I'm sorry, that's steering state. This is going to be passing a body. And we're also going to pass it a bounding radius. And like I mentioned, I said I'd explain what the bounding radius is. That essentially is just the radius of the object, so pretty much like the area of effect that it's in, kind of how much space it takes up. I'm sure it kind of makes sense, the bounding radius. But so let's kind of get some references that we'll be using set up as some of these member fields at the top here. We need a reference to that body so we can send it throughout these methods. So we have body, easy enough. We have this Boolean tagged, and I'll explain what that is later on. That isn't necessarily important right now, but there's these tagged methods that we need to set. So it'll be good to keep track of that. And then we also have the speed constraints. So the first two we have is max linear speed and then max linear acceleration. And then we have the max angular speed and max angular acceleration. Okay, and then we also have that bounding radius that we want to keep track of. So bounding radius. Okay, perfect. So now we got all those fields set up, and things are starting to kind of come together. We're going to set that body to the body that's passed, and then this dot bounding radius equals bounding radius. All right, so as I mentioned, this is going to be a little boring right here. I'm just going to be filling out those methods, and there's these two methods that I want to cover once we get to them. They're a little bit more special or unique. So let's just get some of these filled out first though. Get position on the body, and get orientation is actually body.getAngle. So orientation is pretty much just the direction that the body is facing. Get linear velocity, again, fairly straightforward. The method is actually called that, body.getAngular velocity. And this one is just bounding radius. Tagged, we're going to return tagged. This dot tagged equals tagged. Okay, new vector is just new vector2, just pass that. And we'll jump over these real quick, just fill out the rest of them. So return max linear speed. This dot max linear speed equals max linear speed. This dot, or I'm sorry, that should just be max linear acceleration. This dot max linear acceleration equals max linear acceleration. Angular speed. This dot max angular speed. Again, apologies, this is a little bit boring, I'm sure, but in the end it all works out to be a pretty nice feature to implement once you've got everything taken care of. angular acceleration, this dot max, angular acceleration equals max angular acceleration. Okay, cool. So we got all those worked out. We're definitely not there just yet. There's still a few things we need to make on our own. As you can remember me saying, there's an update method which will be used to kind of process the steering behavior, whether or not we have a behavior to work with, which kind of moves the AI where it needs to be. So to get back to these vector to angle and angle to vector methods, before we forget, I have a special util class that I can use, and I'll show you that method after I fill these in. But I just call these methods from my steering utils dot angle to vector, alt vector, angle. Okay. And let's jump into that real quick. So in my utilities package, I go to my steering utilities, and these are the two methods. These pretty much just translate vectors to angles and angles to vectors. It's just common math that's used a lot with angles and vector manipulation kind of stuff. So I'll just leave this up for just a second so you guys can kind of see what's going on here. It just does some small calculations, and so with that, I think you guys can pretty much pause the video if you need to copy this down. But that's just pretty much what we're using here in the vector to angle and angle to vector, and that's kind of what it uses to be able to change the orientation of the body depending on where it's going, the speed of the angles. So it's always facing forward depending on the direction and speed it's going in. And that's what's going on there. So that'll be able to calculate the angular speed and whatnot. So I believe the next thing we want to get going for us is we should probably include these two objects or fields. One is going to be the steering behavior, and that is going to be a vector 2 again, and that is because, like I said, we're working with a vector 2 kind of position, so that's the kind we're going to be passing. And we're just going to call this behavior. And this is going to be the behavior that we set for this AI entity. And that'll kind of tell it what kind of behavior it has and what it's going to be working with and how it's going to move. And that could be anything from the arrival to avoidance to grouping to hiding. Just there's a lot of them in there. So we need a reference to that so we can set it, unset it, turn it off, on, that kind of deal, change it and whatnot. And then we also have a steering acceleration object. And that's also going to be vector 2 again for the same reasons. And this is going to be a steering output as the name. So the reason we have this is because when we use our behavior, it's going to calculate all the AI, like how it should move, how fast it should be moving, and the direction it should be moving to. And it's going to throw all that into the steering output. And pretty much you just apply the steering output to the body, and that'll move the body as described by the behavior that is set. So that's why we have that. This is just pretty much, we don't even really need to keep a field for this, but I like keeping it at the top just to keep these two together so we know what we're working with. So now that we have most of this worked out, I'd say let's clean up the last few small methods and set up the skeletons for the next few methods, but we're not going to get into the nitty-gritty just yet. This video might seem a little bit boring at first, but you know, it takes a little bit of time to get things going at first for something that might be a little bit more complex than most people are used to working with. And but as you can see, things have been pretty easy so far, just getting these methods filled out. They're all one-line methods, easy going. So let's jump back into our AI steering state to see what methods we still have to create. So we have this set behavior method. That's a pretty easy one to get going. We could probably do that. And then we have a get body method. That's also pretty straightforward. And then we also have the update method. And we're going to wait on doing that one in this video. So let's get the get body and set behavior and get behavior method. So public void, or I'm sorry, that should actually be body, get body, return body. So that way we can get a reference to our body and do all sorts of stuff with it. And then we can also do public, let's see, that should be void set behavior, or I'm sorry, that should be steering behavior. And that's also going to be vector2 behavior. This dot behavior equals, I'm sorry, let me scroll down a little bit for you guys, behavior, okay, and then public steering behavior vector2, there we go, okay, get behavior, return behavior. Okay, perfect. So now I got those pretty straightforward methods set up. That clears out a lot of the red lines. However, we're still not there yet. We're not going to get anything moving as far as interaction with our actual AI. So we're going to have this public void update method that's going to take in our delta value so it can scale the movements properly. And now that that's filled out, I believe now we can just run our game. But keep in mind, we still can't do anything yet because we're still waiting on before we approach the update method and apply the steering. So now you'll notice he doesn't really follow me, but things are still running well. We just have to apply the behavior now, and that's all that's really left. So in the next video, we're going to get a little bit more into the meat of how to really apply the steering behaviors to a Box2D entity, and I think that's going to be a pretty fun one to mess around with, because once you get what we have set up so far, the Box2D steering entity, you can plug in any steering behavior you want, and that's what makes it so flexible. It's just very universal. So with that, I hope you guys enjoyed this introduction video so far, and hopefully you'll stick around for the next few. And of course, I have a bunch of other videos coming out soon. I had a few requests for implementing various collision response techniques such as like probing, AABB, intersection response, and separating axis theorem. I know how to get all those thrown together, and I actually have a few that are in place in some of my little projects that I've made back in the past. So I'm going to be digging some of that up so I can show that to you guys. So with that, hope you guys liked the video again, and like, comment, subscribe as usual, and thanks for watching.